Today I will be explaining our senior project, which is a cooling system for photovoltaic solar cells. Let me begin by showing you this. This is a monocrystalline single junction solar panel with output power of 1.5 watts. This is sheet metal on the back of the solar panel. This was fabricated in the GIC labs. The next thing is our cooling plate. This was designed by 2016 SolidWorks, and inside of that, you will not see it, but there are channels inside to provide cooling system for our solar panel. The next thing, this cooling plate was designed by SolidWorks 2016 and printed using Ultimate Maker Cura, as well as our mirror holders and mirror stands, as you can see over there. And this mirrors was fabricated as well, and our project is using these mirrors to concentrate the solar or the sunlight to the solar system. And we use these mirrors so that we have more control and more concentrated sunlight. We could have used Fresnel lenses, but we will have a limit, so that's why we chose mirrors over there. And as you can see there, we have this wooden board. This was fabricated in the GIC labs as well. And as you can see, it's flexible. We can move it up and down because we are performing our experiment in the winter, and the longitude and latitude is changing, and the sun is horizon, and it's not perpendicular to our project. The next thing that we fabricating the stand for the cooling plate as well. And as you can see here, this is our cooling system. We have the tank, we have the heat exchanger, and we have the fan and the pump. Fan itself has a flow of 200 meter cube per hour, and it works by suctioning the air from the front of heat exchanging. And as you can see here, there are 20 copper tubes, and then the air will flow outside our project. The next thing, as you can see, there is a pump, and the pump is taking the water from the heat exchanger, suction it with a flow of 7.2 liter per hour, discharge it to our cooling plate, where it cools the solar panel itself, and then discharge it again to our tank. And it's as you can see, after the tank is filled, the water, the heated water, is again recycled into heat exchanger so that it can cool again, and the fan would cool it more, and the pump will suction it again and circulate it around our system. My collie is focusing the fifth mirror. This is experiment without cooling, as you can see. Now the light is concentrated in the solar panel, and my collie will take the reading using lux meter, as you can see.
235.5.
235.5. Okay. The next thing we will do is taking the temperature using a thermometer, and finally taking using multimeter to measure the fault.
57.5 voltage.
8.59.
Okay. Current.
0.323.
3.
2, 3.
Okay, now as you can see, all 7 mirrors are adjusted and focused to our solar panel, and as you can see, our cooling system is working. And now we will start performing our experiment to find out what are our results. The first reading that we will take is using lux meter and finding out what is our lumens. 386 kilolux. Okay, that was the first reading. The second reading using thermometer to find out the temperature of solar panel.
34.6.
Okay, now we are using multimeter.
9.34 volts.
And our current
372.
0.372. Okay. And now we will measure our inlet and outlet water.
This is the outlet, isn't it?
This is the outlet temperature. And we are using
Give it
thermocouple.
some time.
The outlet temperature is 25. Now we will check our inlet temperature. Thermometer. Okay, after collecting our data, as you can see, we started from 0 mirror or no mirror until 7 mirror. And as you can see, the temperature is varying, inlet and outlet, voltage as well is increasing, as well as the current. And that gives us as output power, as you can see, almost 4.4, and luminous as we took it before. And this is actually very good result, as our cell was built to take 1.5 watts, and as you can see, as we concentrating our mirrors, the values of the power is increasing, which shows very good results. And this is of course with cooling. And as you can see here, without cooling, also we took it from 0 to 7 mirrors, and the temperature is rising as well, as you can see there. Voltage is rising and current as well. The output power is varying because as the solar panel is heated, without cooling, the efficiency is varying over there. That's why you can see their output power is varying. It's increasing but still varying, not in a constant or fixed numbers over there. And this is our elements. But again, as I showed you there before with the cooling, the values were very good, and we got almost double the output of the solar panel. Thank you.